What is up, my grouping groupies? We are going to learn about factoring by grouping today. This is a topic that I found many of my students have a tough time with. And I think the reason is because it's something that doesn't always work. And in math, we like things that always work. If you learn this process, if you do something, it should always work, right? And when things don't, when it sometimes does it, but sometimes doesn't, I know students have a hard time with that. So what I want to do is first encourage you to hit the subscribe button and the like button because I am coming out with content all the time to teach you all the good math that I know. But secondly, I want to emphasize that very often a good way of recognizing that you're going to have something that's factored by grouping is if you have four terms. All right, I have four terms in this. Most classes, most algebra classes, they start off like this and they say, hey, factor this by grouping. Or the problem might just say factor. Okay, now these don't have any common factors in them. I can't pull out an x from everything. I can't factor out a 2 from everything. So that's pretty much as that method of grouping, of pulling something out of everything, that's out of the question. So what I do need to do is look at this and see, well, what can I do? Can I factor this by grouping? And like I said, oftentimes when you have four terms involved, that's kind of the indication that you're going to have something that's factored by grouping. So I'm going to group these. I'm going to make two different groups. All right, because I notice that these two share some factors in common, and these two share some factors in common. So let's actually write this as what they factor as. So what do these two have in common? They have a factor of x squared in common. So let's undistribute that. Let's factor that out. When I pull x squared out of x cubed, I'm left with x. When I'm pulling x squared out of negative x squared, I'm left with negative 1. Okay, so I've grouped these two things together because they share common factors. Now let's look at these two right here. What do these have in common? They have a 2 in common. All right? And when I pull that 2 out, I'm left with an x right here. And when I pull 2 out of negative 2, I'm left with negative 1. Now I've written what I have so far in this way because this is one of my personal pet peeves. It's technically incorrect, and I see a lot of students doing it. They don't put anything right here. These are still being added together. If you just write these together, it implies that it's this times 2 times that. And it's not. These are still added together. So what I have here are two terms. Remember, terms are things that are separated by addition. So I have these two terms now. Okay, I had four terms, now I have two. And if you'll look, these two terms now have a common factor. I can now factor out an x minus 1 from each of these terms. Okay, so this is how you know that you're going to factor by grouping, is when you do this process, these two terms that you're left with have stuff in common that you can pull out. Right? I can pull out an x minus 1. And when I do that, I'm left with just an x squared right here. I'm left with a 2 right there. And there's nothing else I can really do to this, so this has been factored by grouping. Okay? Now, another thing that I know concerns students is, do you have to do it this exact way? Do you have to factor in exactly the way that I've done it, or you're going to get the wrong answer, or you're not going to get any answer at all, and you're going to lose a bunch of points, and you're going to fail this class, and you're going to have to take it again, and math is difficult, math is hard, and oh my gosh, nobody can possibly understand this because there's too many rules. Okay? Fortunately, we can do this problem a different way. So if I wrote x cubed minus x squared plus 2x minus 2, this is the problem that I was given. Maybe I'll group it like this. I'll group the x cubed and the 2x together because they have a factor of x in common. Okay? And I'll group the negative x squared and the negative 2 together because they have a factor of negative 1 in common. Okay? Does looking at the problem like this change the answer? And the answer, fortunately, is no. Right? So we can do that. So let's group these two together. Again, what they have in common is they have that x in common. So we'll pull that x out. We're left with x squared here, and we're just left with a plus 2 right here. All right, what do these two have in common? Really not a whole lot except for a negative 1. So negative 1 times x squared plus 2. So now I have two terms in this problem, and they share a common factor. They share a common factor of x squared plus 2. So I can pull that x squared plus 2 out, and I get x minus 1. I get an x from here when I pull this out. I get just a negative 1 right here when I pull the x squared plus 2 out of here. And it's the exact same answer that I got up above. Right? Remember, the commutative property says it doesn't matter what order you multiply things in, like this. And so I get the same exact thing. Every single problem that I have prepared for this video operates in that way, that you can factor it, you can group it together in different ways, and you're going to be okay. All right, so no need to freak out, no need to fret. These problems can be done in different ways, and you can still arrive at the same answer. You don't have to see them one exact perfect way. So let's look at another problem. Now, the terms are not written in descending order, and that's on purpose because they don't have to be. But, all right, so the way that they're actually written, they have some things in common. So I'm going to group them like that. And I like to write lines under them so I can keep track of what I've grouped and how. But these two share a factor of t in common. So I'll pull that out. Okay? And what I'm left with, when I pull a t out of t cubed, is a t squared. And when I pull a t out of negative 4t, I'm left with negative 4. What do these two have in common? They have a factor of just 9 in common. So remember, don't forget that plus right there. This is not all being multiplied together. It's still separated by this addition right here. So I pull a 9 out and I'm left with t squared minus 4. And now I have two terms that both share a common factor of t squared minus 4. So when I pull t squared minus 4 out of here, I'm left with a t. And when I factor it out here, I'm left with plus 9. And if you see that I'm not done yet, you get a bonus point, because this, I just did my factoring by grouping. That's the thing that we're learning in this video. But there's still more factoring that I can do that we learned in the previous, or one of the previous videos that I've made, is that this is a difference of squares. It's very important to recognize this thing as factorable. Now in this problem up here, this x squared plus 2, that's a prime polynomial. That does not break down anymore. If you don't believe me, try it. This one right here is a difference of squares. It can be broken down further. Remember, a difference of squares, this in particular is t plus 2, t minus 2, all right, and then t plus 9. So not only did we factor this by grouping, but we've also used previous knowledge, the fact that this is a difference of squares, to factor this even further. And again, if you want to check your answers, if you want to make sure that you're correct, foil this out. And it's going to be super duper foil because you foil this piece out right here, and then you multiply by this t squared plus 9, or I'm sorry, this t plus 9. You should get the polynomial that you started with. Okay? So always check your work if you have the time. Let's do another problem. 2x cubed minus 5x squared plus 2xy minus 5y. Oh my goodness. There's not just x's involved, now there's y's involved. All right? No problem. I'm going to group them like this. Once again, you don't have to. If you wanted to group these two together because they both have 2's, and these together because they have negative 5's, by all means do that. I'm just doing it this way. You can try it the other way. Make sure you get the answer that we're about to get. So, what can I pull out of these two here? They both share a factor of x squared. So when I factor x squared out of 2x cubed, I'm left with 2x. When I pull an x squared out of negative 5x squared, I'm left with negative 5. And that's that first term. Plus, what do these two share in common? Just a factor of y. And when I pull a y out, I'm left with 2x minus 5. And I now know that factoring by grouping was the way to go, because these two terms both share a factor of 2x minus 5 that I can now factor out. And when I do so, I'm left with x squared plus y. And that's actually my answer. I can't factor anything else out. This x squared plus y is prime. It doesn't break down anymore. So I know that I am done. All right? Might as well do one more problem just to make sure we got the hang of this. Let's do 6p squared plus 5pq squared plus 30pq plus 25q squared. All right, so we can group these in many different ways. I'll just do it how it's written. That's one way of doing it. I can't factor anything out of 6 and 5, but these both have just a single factor of p in common that I can pull out, leaving me with 6p plus 5q squared. Alright, now what do these have in common? Let's see, 30 and 25, these both share a greatest common divisor of 5, so I can pull that out. And they also have one factor of q in common. They don't both share a p, but they both share a q, so I can pull that q out, leaving me with 30 divided by 5 is 6, and then this p remains, but I pulled this q out, plus when I pull a 5 out of 25, I'm left with 5, and then I pull a q out of q squared, and I get that right there. Alright? And I made a mistake when I wrote this problem down. This should actually be a q cubed. My bad. Alright, so when I pull a q out of q cubed, I get q squared. Alright, now these are the same exact factors in these two terms right here. Alright, so now I can pull that out, and I get 6p plus 5q squared. When I pull this thing out of both of these terms, here I'm just left with a p, here I'm left with a 5q, and there's my answer. Once again, FOIL this out, distribute it, make sure you get what you started with right here. Alright folks, thanks for watching. If you learned something, please hit that subscribe button. Please like this video. Coming out with content all the time, so I just want to basically teach all the math that I know on this YouTube channel. And as always, for some extra practice to make sure you do in fact have factoring by grouping down, I've created these 3 problems, and I'm going to put answers to them down in the description below. So thanks for watching. I really appreciate it. Enjoy your factoring by grouping, and I'll see you next time.